Okay, our objective for today, I can multiply polynomials. Read together. 1, 2, 3. I can multiply polynomials. So we don't need a fair model because we already know what polynomials are, right? Tell your neighbor the definition of polynomials. Okay, thank you. Yes, monomials or some more difference of monomials. So we don't need a fair model. We have that. We have the steps. We're going to continue using these steps. It says here we distribute, identify like terms, use commutative and associative property to combine like terms, and simplify. We always simplify to lowest terms if possible. So before we move on, a reminder, look up to the screen. We're no longer in addition and subtraction, is that correct? We're going back to multiplication. So I remind you, when we multiply exponential expressions of the same base, what happens to the exponents? You add. Are we there so far? Okay. All right. Copy this one. Example Q. 2 times x. So I'm going to do a presentation for this using 3 different methods, using tiles, using distributive property, and using the area model. Okay? So I'm going to write first on this side, tiles, using distributive property, and using area model. Okay? So, using tiles, let's see, I'm going to try and refresh your memory. I did a presentation using tiles the other day on combining like terms. Remember that? When we did the whole pet shop, and then from there I showed you with tiles how to combine and stuff like that. Who remembers, let's see, tell your neighbor, what figure does X represent? What figure does X represent? See if you remember the tiles. Okay, I'm talking about no more animals, I'm talking about tiles. Remember when we did the tiles? Okay. Let's see. Who said a green rectangle? Yes, that is correct. Yes, that is correct. So, what's inside of the parentheses and X? There it is. This says, the factor tells me how many times to repeat that. 2 times, so I draw another one. So if you have your color pens, draw 2 green rectangles. So the next question would be, do we have any 0 pairs? Any 0 pairs? No. No red ones, so that means 2x, if I represent it with tiles, and I see here how many x's do I have? 2 of them, so I just write 2x. Fairly simple. We're taking baby steps right now. This is just so that we can get used to the format. Now let's do distributive property. We got 2 times x. Okay? So now, when we distribute, I'm going to distribute the 2 inside of the parentheses to each term. How many terms do you see in here? Only 1. What would be the coefficient here? 1. So therefore, what is 2 times 1? 2, and you bring down the x. That's using distributive property. And the last method is using the area model. I'm going to draw a nice rectangle here, nice and straight. If you can draw one just like mine. And I'm going to write on top the x, and on the height, I'm going to write 2. And once again, the coefficient is 1, therefore 2 times 1 is 2, and I bring down the x, and that's the area. Now, I'm presenting both of these to you because the area model we're going to use later on when we do more of the factoring of the quadratics of polynomials, but I just want to see how you see it using multiplication. So with that said, any questions with these? No, Mr. Q. All right, good. Example, super cute. Copy this one. 3 parentheses times negative x squared. See if you can do that one in all 3 methods. and see if you remember what figure, don't tell your neighbor yet, what figure it was the x squared. Copy that, show me 3 methods. Go. All right, let's see. Everybody said that it's a what? A red square, is that correct? So let me make some room here. Hold on.
Wait, like a big square?
Yeah, the big square. Yeah, the small square were yellow, and they counted as ones. Remember that? Yes, Mr. Q. All right, good. So, big square. There it is in red. How many times? 3. 1, 2, 3. So, do we have any 0 pairs for the big squares? No, so this is negative 3x squared. That's what I see. Distributive property, I got 3 times negative x squared. I'm going to write my coefficient, which is what? Negative 1, Mr. Q. All right, good. So 3 times negative 1, that is negative 3x squared. And last but not least, the area model. Three times negative x squared. Once again, I'm going to write my coefficient. So what is 3 times negative 1? Negative 3, and I bring down the x squared. Okay. Now, I just wanted to introduce using the tiles because I don't like to stay a long time with tiles. I just wanted to see how it applies using manipulatives. But for these next ones, I want you to do those using only distributive property and area model. So you remember which methods you're going to use? All right, here we go. Copy these 2, please. Example C and example D using distributive property and area model. It reads, example C is 3x times 2x, and example D is negative 8x times 5x squared. Copy that and go. All right, check with the neighbor, see what they got for C and D. C and D. All right, here we go. So I'm going to use distributive property. I'm going to distribute this in here. So 3 times 2, that's 6. X times x is x squared. Let's do D. Distribute this in here. Negative 8 times 5, that's negative 40. X times x squared is x to the third. And the same thing with the area model. Yes, sir. Well, we're multiplying. Yeah, that's fine. Yeah, but, I mean, if they already have it like this, just might as well write it. Because right now I'm going to give you something that has, like, 3 expressions with parentheses. So we'll get there. Any questions with these so far? We're good? Yes, Mr. Q. All right, good. So, copy these 2, example 1A, 1B. See if you can go a little bit faster now that you got the process. Use any method you want, either distributive or area model. Yes, sir. Yes, ma'am. Sorry. For D? Yeah, x cubed, because this one was to the first power, to the second power. Since we're multiplying, what happens to the exponents when we multiply? You add them. Okay? So now we're no longer in addition. I know some of you are still thinking like, wait a minute, do we combine? No. We're multiplying, so we add the exponents. Copy that and go. All right, let's see. Volunteer for A. Who's got it? Yes.
I got, so I did a problem or did I say
Answer.
18 y to the 8.
Hands, have you got that? Okay, pass it to someone. Emily, what'd you get for B? Hands, have you got that? Okay, we got this, yes? All right, let's crank it up a notch. Here we go. Copy this one. Example 1C, parentheses, 1/4 s squared t squared, close parentheses, open parentheses, st, close parentheses, open parentheses, negative 12 st squared, close parentheses. In the previous class, they were like, why are there letters in math?
Yeah, it's math. Like, English and math are supposed to be opposites, so why are we learning the alphabet?
You guys are funny. All right, here we go. Look up, please. Did everybody copy it? Okay. First of all, does everybody notice that there's multiplication throughout? Okay, multiplication here, 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 everywhere. Therefore, if I was to use the commutative and associative property, I can. Is that correct? Okay. So I'm going to use it so I can show you those two properties, but then we'll do just the multiplication by numbers and variables of the same base. So watch. I'm going to start by identifying the numbers. So I have 1/4 and negative 12, so I'm going to write it here. 1/4 times negative 12. Why? Because I'm using what property? Commutative property, right? Times. Same basis. S, S, and S. So I'm going to write S squared times S times S. Now, here somebody asked me earlier, they're like, Mr. Q, but they don't have the same exponent. Why am I writing them together? Talk it over with your neighbor. Why am I writing them together and even though... Okay, who can elaborate for us? Axel. We're not adding anymore, so we're not combining. Now we're actually multiplying the same bases. Very good. So then here we have same bases again. T squared times T squared. So now I'm going to group them. These, and these. All right. So 12 times 1/4, if I write this over 1, this is negative 12 over 4, which is negative 3. Yes? Same base. This is S. What are my exponents? 1, 1, and 2, so that is 4. And this one, same base. We have exponents 2, 1, and 2, so this is 5. All right, that's showing the properties, right? Now, if I was to do this without showing the properties, what would I do? Let me show you. Here it goes. Since I'm multiplying, I can multiply these two. Negative 12 times 1 divided by 4, that's negative 3. S squared times S, that's S to the 4th. And that is T to the 2, 1, and 2, that is 5th. Yes? Okay. Okay, you try it. Here we go. Copy this one. Example 1F. We got 1/3 x squared y times 12x cubed z squared, close parentheses, open parentheses, times y to the 4th, z to the 5th. Copy that and go. Okay. Beto, what'd you get? Okay, Brian, what'd you get?
I got 4 x to the 5th power, y to the 5th power, z to the 5th power.
Hands if you got that. That is correct. Okay, let's kick it up a notch. Let's continue. Here we go. Okay, don't copy this one. Look up. We've already done these, and if you notice, all we do is multiply and distribute into each term. So this would be 12x squared plus 16x minus 32. Is it in standard form? Yes, 2, 1, 0. Can we combine anything? No. This will be our result. Is that correct? So if I was to give you this one, same thing. 2 times 4, 2 times 1, 2 times 3. Everybody got that? But where I want to get to is these. Copy this one, please. Example 2C. 2C. Example 2C says 6PQ, parentheses, times 2P minus Q. And we're going to do this one using both methods, using distributive property and area model. I just want you to, I want to see if you see what I see. Do you guys see what I did? No? All right. Okay. All right, here we go. Everybody copy that one? Okay, let's do this one together. Question. How many terms are inside of the parentheses? 2. So we need to make sure we identify there's 2 terms. Okay? So the first thing, I'm going to distribute this to the first term. First term. Not numbers times numbers, which is coefficients times coefficients, variables times variables. Are we there? So, what is 6 times 2? 12. What is P times P? P squared. What is Q times, is there another Q here on the first term? No, I just write it in there. Let's do the second term. I'm going to switch colors just to keep it organized. What is the coefficient on the second term? So it's now it becomes a negative 1, right? So what is 6 times negative 1? Negative 6. P times, does this one have a P? No, just write the P right here. Q times Q, that is Q to the second. Now question, we're done with multiplication here, right? Here, there's subtraction here. Can we combine these two? Talk it over with your neighbor, can we combine these two? All right, let's see. Matthew, can we combine those? Why not?
Because they don't have the same variables.
They don't have the same variables. They do have the same variables. The exponents. So they're not like terms. Does everybody agree with that? This one is P squared Q, and this one's PQ squared. What are the degrees for each term? 3. And 3, so therefore, we're done. Of course. Copy this next one, please. Oh, sorry. Area model. Let's do the area model next to it. Thank you, Felipe. Everybody say thank you, Felipe. Here we go. 2P minus Q. And then the height is 6PQ. Now, when you get to the area model, look up, please. We're going to split this area of the rectangle into 2 areas. Look up. The first term ends here, and I draw a line down. And now I have a second term, that means a second area. Does everybody see that? Therefore, multiplication goes the same. So I'm going to multiply this times the first term. 6 times 2, that's 12. P times P, that's P squared, and I write the Q right there. Same thing with this one. I write my coefficient of 1. 6 times negative 1, that's negative 6. P times nothing over here, I just write P. Q times Q, that's Q to the second. And that's how you do the area model on these. Everybody got it? Okay, let's see if you can do this next one by yourself, both distributive and area model. Here we go. Copy this one. Example 2D. We got 3AB times 5A squared plus B. Copy that and go. Okay. Hannah, what'd you get? Hands if you got that. That is correct. So, we got this, right? Our what? Okay, fine. Last one, though. Challenge one. Ready? Here goes the challenge one. Example, super duper cube. Here we go. Negative 3a squared bc, parentheses, 2a plus 3bc minus 6ac, close parentheses. Now the challenge on this one would be how you do the area model. Distributive property, I can see you doing it. I want to see how you do the area model. Ready? Go. Okay, let's see. I'm going to do distribution. This becomes negative 6, a to the third, bc. This becomes negative 9, a squared, b squared, c squared. This becomes positive 18, a cubed, b c squared. And see if it did up to right there, okay? Let me check for standard form. This is 5, 6, 6. So far, so good? So how would I write this? Let's see. Yes? Yeah, well, that's what we're doing. Hold on. Anyways, make sure you write in standard form at the end. Home plate for tonight. Home plate for tonight is on pages 506, 507, and you're only doing numbers 1 through 23 odds. All right. Hold on. Good one, guys. Enjoy your home play. See you guys tomorrow. Bye.